Dear students, I have come with a new module, Computation of Regression Coefficients and Pearsonian Correlation Coefficient. These are related concepts, and in this module we will learn how we can calculate Pearsonian correlation coefficient using regression coefficients. And we will be doing one problem also to prove this. So if you see the introduction, the constant b in the regression equation is called the regression coefficient. Now we have two regression equations, that is regression equation x on y and regression equation y on x. So we have two regression coefficients. So as I told you, the first one is regression coefficient x on y and the second one is regression coefficient y on x. The regression coefficient x on y is bxy. It's also denoted as bxy. The regression coefficient y on x is also denoted as byx. Now, so this regression coefficient x on y. So you can see that either it's represented as b or bxy. Now, what is the use of this bxy or the regression coefficient? This regression coefficient will measure the change in value of x corresponding to a unit change in y. We know that we can use this regression coefficient and correlation coefficient values for predicting. If this is the sales you want to achieve, what should be my advertisement budget? If this is the savings I want to achieve, then what should be my income and what should be my income tax? So we can predict the related things. So that is why we are learning this concept. So byx or bxy, the computation is important, and from there we can compute the correlation coefficient, and then we will use the values for prediction. So bxy, if you take, this is calculated as r into standard deviation x divided by standard deviation y. So r is the Pearsonian correlation coefficient. Standard deviation x, that is also known as sigma x, but the symbol is different. It's not the sigma we are using for calculating arithmetic mean. That sigma is different, but the standard deviation sigma also we are calling it as sigma x. Sigma x is standard deviation of x series. Similarly, standard deviation of y series, that is sigma y. Now regression coefficient x on y. If deviations are taken from actual mean, what will be the equation? So bxy is equal to sigma xy divided by sigma y square. But if you are taking deviations from assumed mean, bxy is equal to n sigma dx dy minus sigma dx into sigma dy divided by n sigma dy square minus sigma dy the whole square. Now if the regression coefficient y on x, it's represented as b or byx, that what is its use for? So that is, it measures the change in y corresponding to the unit change in x. So we can use this for predicting the values. So byx is equal to r into sigma y divided by sigma x. We know that r is the Pearsonian correlation coefficient. Sigma y is the standard deviation of y series. Sigma x is the standard deviation of x series. Regression coefficient y on x. So if deviations are taken from actual means of x and y series, we have two equations. One is we are taking deviations from actual mean, and second one is we are taking deviations from assumed means. So when we are taking deviations from actual mean, byx is equal to sigma xy divided by sigma x square. If you are taking deviations from assumed means of x and y series, byx is equal to n sigma dx dy minus sigma dx into sigma dy divided by n sigma dx square minus sigma dx the whole square. Now calculating correlation coefficient from the regression coefficients. So we have two regression coefficients, bxy and byx. That is, equations are r into sigma x divided by sigma y. Next is r into sigma y divided by sigma x. Now we can multiply this, that is r into sigma x divided by sigma y into sigma y divided by sigma x. When you cancel the common values, bxy into byx is r square. It will get cancelled. Sigma x and sigma x will cancel. Sigma y and sigma y will get cancelled. So you are getting bxy into byx is r square. Correlation coefficient is therefore b1 into b2, that meaning square root of regression coefficients. It can also be expressed as square root of bxy into byx. This is an important relationship, and we will be doing problems also based on this, and this is very important in predicting the values. Now some important information I want to give you. This will help you in your computation. In the exam hall itself you can check that whether you are going wrong with the computation. So first thing you have to remember, correlation coefficient value cannot exceed 1. So if you are getting a value more than 1, you know that your calculation is wrong. Again recheck and correct the value. Second one is, so regression coefficient value must be less than 1. Now we have option because we have two regression coefficients. So the next point is, in other words, both the regression coefficients cannot be greater than 1. So both the regression coefficients also you have to remember that will have the same sign. Either it is positive or negative. And one more thing, I am emphasizing the point. See, if one regression coefficient value is more than 1, the other one should be less than 1. Then only when you take the square root, you will get the correlation coefficient not exceeding 1. And another important rule is, both the regression coefficients will have the same sign. It will be either positive or either negative. So if you are getting different signs, there also you can make out that your calculation went wrong. So you have to recheck the calculation and correct it in the exam hall itself. Now one problem we will do. Find out the regression coefficients of x on y and y on x from the following information. So values of x 3, 2, minus 1, 6, 4, minus 2 and 5. Values of y 5, 13, 12, minus 1, 2, 20 and 0. Now this table will explain the computation. I have used 2 as the deviation for x series and 7 for the deviation for y series. So x values are there, dx values are there, dx square values are there, y total is there, dy total, dy square and dx dy. These total values are important because with this we are going to do the computation. Now you have to calculate the bxy, that is the regression coefficient x on y. You know the equation, n into sigma dx dy minus sigma dx into sigma dy divided by n sigma dy square minus sigma dy the whole square. Now you substitute the values in the equation, we will get b is equal to 7 into minus 132 minus 3 into 2 divided by 7 into 372 minus 2 square. That is b you are getting minus 0.35769. Now we have to calculate the next regression coefficient, that is regression coefficient y on x, or we denote it as byx or b2. So that is computed using the equation n sigma dx dy minus sigma dx into sigma dy divided by n sigma dx square minus sigma dx the whole square. Now we have to substitute the values in the equation, we will get b is equal to 7 into minus 132 minus 3 into minus 2 divided by 7 into 55 minus 3 square. So byx or b2 is equal to minus 2.473. So now we got both the regression coefficients. One is exceeding 2, one is less than 1. So now you have to calculate if you want to calculate the Pearsonian coefficient, how you calculate? Pearsonian coefficient r is equal to, or the correlation coefficient r is equal to root of 0.35769 into minus 2.473. So you are getting, always you have to remember that when you are taking the minus sign, that minus sign will be outside the square root. So that is minus 0.9405. So that is how both the regression equations are getting the same minus sign. So here is both the regression equations, minus 0.35769 and minus 2.473. So both the regression coefficients have the same sign and the value of correlation coefficient is also less than 1. We are calculating the square root, taking the minus sign or plus sign outside the square root. So the regression coefficient values will have the same sign for the correlation coefficient also. So this is what I want to explain in this module. Thank you.